robots. We all love them, especially if YouTube recommended this video on my channel and you're watching this video on your timeline. Then definitely as someone who's interested in robotics, electronics, embedded systems engineering and technology as a whole. So in today's video, I'm going to go over how I design a simple remote controller circuit for the next robot I'm building. Yes, I'm not going to say what exactly it is because it's going to be next or the video after that, between one of the two. This is purely not scripted, unlike my other videos. So this is more or less a filler video, and it's for those of you who have asked, okay, what software do you use to create your circuit diagrams I use for your display. Of course, this isn't the software that I plan on using for or that I use for developing PCBs. So that's quite a little bit of a different software, which would probably be KiCad. But this is just for being able to have display circuits, circuit diagrams. It's a diagram in the end that is easy to interpret, easy to look at, allows you to follow wiring, and you can use to solder your own variable board before fully committing to a PCB. So it's actually one of the processes I use in the current robot I'm building, where I fully designed the circuit board after doing a bunch of testing, and then did it on a breadboard, moved it to a variable board, soldered all the connections, and then I found a very fatal flaw in the process of doing that, which allowed me to rectify that before I had made the same mistake with a PCB, and that would possibly have cost me way much more. So in today's video, we're going to be designing a remote controller for my next project. So let's get into it. Alright, so the first thing that happens is that you do a drawn diagram on a piece of paper, most likely, or if you have enough skill, you just simply need to list out all the features. For example, this remote controller needs to have a microcontroller. We are using ESP protocol, the ESP now protocol, for communicating between two microcontrollers. We have two joysticks. We also have three potentiometers that we're using to calibrate something. I don't talk about it, if need to expose pretty much the next video. And then we have an OLED screen. We also need it to be rechargeable too at the same time. So all these features are, and then USB Type-C port for rechargeability also. So all these features are going to culminate into the components that I selected. I've already selected these components. I've already drawn all these diagrams all around. If you want to have a full in-depth into how I usually come around selecting components and from features anyway, you can check the previous video I did. So in that video I did explain, 2 videos ago I explained how to rapidly prototype your projects. And in that video, by explaining that, I explained all the different things that you would need to consider, what kind of components, how components can be interdependent and dependent on each other and whatnot. But leaving that aside, I'm going to be talking about how I designed the circuit, and the software I'm using right now is called Fritzing. So starting off from the very beginning, the first thing I do after I load up Fritzing is to open up my parts. You can see on the right here, where I was searching for battery, I switched the search to joystick because that's the first thing I'm looking for. I have multiple options for joysticks. Most likely they are either the same or different. So what I do is I bring them out and I check if there's any difference between the two of them, and if there's any features that anyone has that maybe the other one doesn't have. And then after bringing them out, I can see them and I can see what they look like, whether it's the one I want to use. I look at the pins and see what the pins labels are, and then I just figure out I don't like these green ones, so I essentially just delete these green ones. And then I take a look at the red ones, and then I want to check the pinouts and the configurations and see if they're the ones I would like to use. As you can see, there's a mislabeling between what's on the screen, or rather what's just on the red plate of the joystick, and what the actual pin is configured in the schematic. So you can see VCC is being identified as GND, VREF is identified as VCC, HOF is identified as VRX, other as VRY, and GND is SW. So you can clearly tell there's a misconfiguration there, but I do plan on using the actual connection based on the schematic, not the one that is not written on the board, because that just makes it a whole lot more certified. So I put my two joysticks there. Then the main thing I do is just to bring out all of the components I need. So I search them up either, and if you are somebody who doesn't have any of these components in Fritzing, maybe it's newly installed, so you can set up ESP2 Fritzing part, joystick Fritzing part, whatever parts you want to set up for the different things. So following this just a bit, I basically drop out all the different components that I want to use for the particular project before I start making any connections. Now I already know these components because I've already done the design on paper, or rather that's what you should do. Me personally, I already had it in my head. I had already listed out the features, gone through it several times, optimized some things, and then just decided, okay, these are the components I need, and then this is the connections that I would like to do. After making a few connections, I start to color code the wires, red for 5V and black for GND. So I color code all the wires, straighten up any of the wires along the way, and then I start connecting all the other components. Of course, there's a switch there which would allow you to power off and power on the circuit in general. This switch comes in between the 5V and GND of the ESP32 because that's where the load directly comes to. So for this particular chip, if there's no load, after some time it goes off. It also has its own personal power button, so you can, maybe the load is below, I think 50 milliwatts or 50 milliamperes, somewhere around there. I can't remember the exact specifications of the circuit, but after using it for a long time, I know that if I switch off the load, it goes off and then conserves battery power and all of that. And then if I switch on the load, it automatically comes on, which is a very, very nice feature. I don't need to do anything about battery charging. It just does and handles everything. Quite a useful circuit. So you can see the rest of the process is simply just me going through all these different connection lines, making sure they're straight. Now I connect up the joysticks, connect them to each other, following the actual schematic. For the joysticks, we need analog pins in order to be able to read the voltage from the joystick's X and Y axis. So the ESP32 has two sets of ADC pins, ADC1 pins and ADC2 pins. When you use Wi-Fi, you are unable to use ADC2 pins to measure voltage anyway. And with that in mind, I have to use only ADC1 pins. I initially was connecting all 4 pins for the X and Y axis for both of the joysticks, but I only realized I only need forward and back on one joystick and I need left and right on the other joystick. The reason why I do it like this is just for comfort. You're used to controlling things like that, so I didn't want to use both. I didn't need to use both X and Y axis on both of the joysticks, so I just picked out the 2, and then so I now have 2 pins occupied instead of 4 pins. That now leaves me room in order to connect the remaining potentiometers, which are 3, each of them requiring 1 ADC pin to themselves. So easily you can search this up, you can check up the pins, you can check up how to use them for the ESP32. After doing that, all I need to do now is set up the potentiometers and then wire them to their 5V or generally, GND or generally, and then wire their individual analog output pins that would be going to the analog pins on the ESP32. Moving from there, the next thing I did was simply to connect the screen, which is an OLED screen that connects via I2C, I2C, whichever one you want to call it, just on the right. And then that just requires you to have an SL and SDA pin. The ESP32 is obviously 3.3V logic, so I rather just run all my connections, all my sensors, everything off 3.3V, unless there's some company that requires 5V. So that way everything is protected, your analog pins, all your pins are protected. And with that, you have a very simple circuit that allows you to recharge itself, power up your system, have two joysticks, have 3 potentiometers for whatever controls are all inputs, and then have a display screen to display maybe whatever is going on. And I don't want to say too much about the circuit because for a future project anyway, but I said to do this just to show how the process works. Now you might be wondering, okay, it's a remote control, where does the wireless communication come from? But like I said earlier, I'm using the ESP now protocol Express if I can't remember the name of protocol anyway, but the ESP32 protocol for communicating between two ES32s through the 2.4 gigahertz signal wire. So I'm assuming it's using the Wi-Fi. You can't use Wi-Fi while the protocol is ongoing. So that means that it uses the Wi-Fi module, which means that ADC2 pins will not be available. So there is no NRF241 like I would normally use in my older projects, which allows you to have a radio communication between two modules or two devices. That's a bit overkill, and this is much simpler. It's built into the device, meaning I don't have to have any external components. Much cheaper, better, and actually way much easier. So the only way this protocol won't work is if your ES2 is damaged, and in this case that's probably not going to happen. Of course, I've damaged some over the years, but yeah. Well, if you like the video, if you like me just doing small tutorials like this, you can comment whatever tutorial you want, and I would probably look at it, see if it's something we can do, and then in one of the subsequent videos, because it's quite difficult to put out full-blown robotics projects. There's things that go on during building the project, 3D printer spoils, this or this happens, there's some limitations, there's ordering time. All these things make it quite difficult for you to push out projects really quickly and really fast. So if you like things like this, if you like engineering, want to see more robotics projects, as this is just a tutorial for creating simple circuit diagrams, subscribe, leave a like, and check out the other socials for Legions and my personal socials. See you in the next one.